Hello, welcome back. Last time I got to actually optimize a program, and that was a whole lot of fun. Didn't get it to any of these spikes, but you know what? I'm okay with what I did. Traffic signal. Once again, we are set to contribute to a piece of a larger system for a company controlled by Sun Haotian. This one is a traffic signal for a 6-way intersection with support for emergency transponders that override the normal traffic pattern. I don't know any more than this. This is going to be complicated. 6-way, huh? Oh dear. Emergency is a simple input connected to a device that detects the transponders of nearby emergency vehicles. Light 0, Light 1, and Light 2 are simple outputs connected to go, no-go traffic signals for 3 different directions at a hexagonal intersection. Okay. Control of the lights should be sequenced as indicated in the verification tab, turning off all lights when an emergency vehicle is detected and restarting the sequence when it leaves transponder range. The durations of... I didn't absorb any of that, by the way. The durations of the phases are set by the operator using dials that can be read as X bus inputs. So when emergency, turn off all lights. I guess that means 6-way stop, basically. So on means go, off means stop. That's what it looks like to me. Alright. So phase 0, phase 1, phase 2. Alright, so 5 ticks this, 4 ticks this, 2 ticks that. 5, nope, interrupted. Then you restart here with 5, 4, 2, 5, 4, nope, interrupted. 5, 4, 2. Got it. Okay. So I understand my output. It's only the one input, other than the fixed values here, that I can move around. Helpfully labeled. So there are 3 states here. I can't just use a gen command to sleep, because I have to poll emergency every tick, because it can interrupt at any time. These are simple outputs. This is a pretty strong case for DX300, because it's just like... just 3 exact values to output to that. So 1, 10, and 100. Durations are set by these. So... still don't really have an overall idea of what I'm going to do here. I do note that an MC6000 has just enough inputs plus 1 to get all this done. Yeah, sure, that can be X3. Alright, so X0 is the 0, X1's the 1, X2 is the 2. P1 does nothing. I have no idea what I'm writing here, though. I mean, first thing is probably tech P0 100. If in emergency mode, move 0, X3, jump weight. Sure. And I might as well also, so I'm going to have to set some kind of... So basically have 2 position values. I have which one of these I'm doing, and... I wonder what the ranges of these are. Got an idea to program one of these with, like, let's see, what would this end up being? So this would be 100, 100, 100, 100, 100, 10, 10, 10, 10, 1, 1. So yeah, do an init, where I read the state of that and write it to one of these. I could try that. The possible problem with that is if these can add up to more than 14 total. But if I'm doing that, then I don't need any more state. All my state is just actually stored in the address register here. And that'd be real convenient, so I'm going to try it. I will need another microcontroller to program that, which is fine. I can just use... it's always going to be phase... Okay, yeah, so I think I can just, like... Oh, I can do better than this. Yeah, okay, here we go. Ideas are coming to me. Okay, so, an MC4000X goes someplace. X0, X1, X2, and X3 is your data. And then this will talk to a different data and probably address there. This seems pretty reasonable. Yeah, because this doesn't actually have to talk to this. Does it? Like, I'm gonna have you just assume... No, you need... Okay, so I do need to initialize... So you initialize it. What if this is set to 0? I don't know the exact... If this can never be 0, and these can never add up to more than 14, this will work. If either of those can be true, this is going to fail, but I'm going to try it. Okay, so late 0, P2 means 100, X3, sleep 1. Okay, so you are going to move X1, no, X0 ACK. Yeah, you might need to get a bit bigger. It's maybe not. Tech ACK 0. It's L1. I can fit loop 1. Not enough instructions, so you might need to be a 6000. Would a 6000 have enough instructions? I think it wouldn't. Sure, that's fine. In fact, that fits more nicely. So yeah, this is just the same. Doesn't fit. How close do I get? This would be 10, this would be 1. Okay, so it sure would be nice if I could do like a function call here. I mean, I can do that with 2 microcontrollers, and I guess that's what I'm gonna do. Okay, so yeah, if I'm not really worried about cost, that doesn't sound like me though. Well, but at this point it is. I'm just trying for any solution. I want to compact this way. So x2 connects to that. x3 connects to this. That's fine actually. SLX X0. This will sleep for 0 ticks if there is stuff to read, so that's good, I think. I probably still have some of that in my pasteboard. X0 ACK. Loop tech X0, sub 1. Move. Move what there? A value, but which value? Technically, all of those values do fit in a simple pin, so if I had a simple pin to spare here, I could, and I would have one to spare here, I could do this. Move P0, X1. I think that's what's going to have to happen. And that means you need to be a big boy. Pin type mismatch, I understand. Got a little cross thing going on here. Part connected to self. Oh, right. Forgot about you. Okay, so now routing becomes an issue, yes, but probably a very solvable one. Hold on, pin type mismatch. No, X0 is here. X1 is here. P1. I can move you over a bit more, I think. Will that solve my problem? No. No, it won't. Unless it will. It almost does. I have to move you one more. Wait, you don't get address. Okay, right. Okay, so that connects. And I might still be able to... Yeah, I can totally route that data in there, and probably the address too, I imagine. I don't know if I imagined correctly though, but maybe... I note that I could do this, and like... have this go... Well, no, that wouldn't help anything. It might. Let's see, I could do this. Have this go here, have this go here, and keep this channel open. Yeah, okay, okay, so that's an option. Getting that spiraling out of control feeling here. And all of this preamble I'm doing is just so that I can, well, so that this can be simple. This can just store the state of its thing in the address field of this, and just read until it hits an emergency, reset the address to 0, do the emergency, and then resume what it was doing. Like, yeah, all this is just to make the downstream stuff simple. So anyway, SLX X0, move X0 ACK, loop tech X0, if not sub 1, move P0 X1, jump loop, and that's it. So you would... Okay, so we're starting with 100. Move 100, P1. Move X0, X3. Move... I need to wait for you to read this value, so I'm going to do this in the other order. There's a little bit of a timing thing going on here, but it's fine, because you do this instruction while this instruction happens, so by the time you need to read the P0, it will long since have written that value to it. So that's completely fine, but I need to do it in this order because I need the pin to stay until you can unblock this instruction here, so that I can move 10 to P1. Move X2, X3, move 1, P1, and then oh. You're not connected, you're right. That puts me in an awkward space because then I can't get to that address pin. I guess so I'm only reading the data. I can read from here and maybe write to this address pin if I can bridge that over. I think that looks very plausible because I can still route all this. That's going to change my values in here, which is completely fine. Okay, so this is the data pin. This is the address pin. Ooh, it fits, but only just. But it does. It's fine. Okay, sure. I think that's sufficient wiring for this. Except for you, right, but I moved you over so that, oh, I put that bridge in there so I could do that, and now that's a problem. Can I route this through here somehow? No, that's a dead end. Unless I can... I don't think so. Because, yeah, I needed to move you over. Oh, and now you can't have the... Okay, yeah, problems are happening. This whole cross that I have to do here sure is awkward. And then this intersects. Yeah, okay, the space didn't work. Maybe I could compact this somehow? To move you left instead of this right? Because, yeah, moving that right is not going to happen. Okay. I don't have another X bus for you. But if I'd use X2 instead of X3 for this, maybe something could happen. No, how would that help? Well, okay, so what if I bridged here? Yeah, here we go, here we go, here we go. I can do this. Alright, it's a little awkward, but it works. Move X0, X2, move X1, X2, move X3, X2. Okay, so that fits now. This is connected to that, and my numbers need to... No, they don't need to change anymore because I didn't reroute this yet. I might still need to, because if I need access to these pins, yeah, I still need to. That remains necessary. So this bridges to here. That goes there. So it's now 0, 1, 0 for the first one. That's light 0. 1, 0, 0 for the second one. And 0, 0, 1 for the third. Sure. And also you need to sleep forever. That's how I'm going to do that. Nothing will ever come from X2. Okay, and this will be sleeping forever. That's great. Alright, cool. You are sleeping 1 at the start of your job. Hopefully this can never start an emergency state. I think that's a safe assumption. This is so cool. I love it. So I think I'm done here. I think this is going to write what it needs to write. Let's see it do that. Yes, okay, so that is the correct output for step 1. You're sleeping. 4? What's 4? 4 is this, right, and you're working on that. This is all fine. Okay, you wrote 5 tens, good, and then you read that 4, so you write 4 100s, cool. It's a real convenient thing that I can hack this value into a simple pin. If I ever needed 2 of these active at once, then that would not work. But this way it does. 2 of those. Okay, great. Cool. Oh, this needs to be no more than 13 because I need a terminator in there. So when it gets a 0, it needs to restart. Okay, and now you sleep forever. Ah, I see what the problem is. The problem is I changed the meaning of that, but didn't change the meaning of this. Okay, great. Okay, so now, your logic. Not yet, your wiring first. Data line. Comes in here and connects to, I don't know, X2? Address line. Goes through here and... Isn't that okay? I can't write to that. I can't go through there. Okay, got a problem. Okay, would wire routing be possible if this were to move down? No. No, it wouldn't. Okay. Could I... Oh dear. Yeah, that's not great. I don't think there's a way to make that happen. So wait, but can I maybe do this? That looks plausible. Wait, what? Does it? Hold on, why would I do that when I can instead just go straight to the data, have the address come through here. Okay, yeah, so using data 0, address 0, that's fine. There's nothing wrong with that. Although I should certainly... Oh, I can't reset the address. Okay, so that needs to be one of the first things you do. That's okay, that's just another instruction, although you're going to be a little short on instructions, maybe. Maybe not, we'll see. But wire routing's going to happen first. Okay, right, so I snuck this through here. That goes to X0, and then this goes to X2. Okay, I did it. Right, I had done that exercise before. It worked just the same the second time. Okay, what a specific layout I needed for this. Alright, so initialize, sleep 1, if emergency, move 0 to X3, also move 0 to the address line, which is... Okay, right, and move 0 to address line is X2. Move 0 X2 on emergency, jump to wait. Okay, so otherwise I move oh hey, no, that's fine. Right, I need to read a line here. Move X0, X3. Okay, so that sets the thing for that tick and advances the pointer. Hold on, not to X3. Tech ACK 0 plus move 0 X2. So write 0 to the address line in that case. and read another value from here. x0 ac. Then move ac x3. Okay, I think I finished with one line to spare. I don't know if I did all that right, though. So I know the first tick is right. Why are you sitting there? Oh, right, because that's after the sleep. Okay, yeah, so that starts on 0. Great. Okay. Tech P0, 100. No emergency right now. Move x0 ac. You read a 10. 10 is not a 0, so it just gets written here. And that's great. Then you sleep 1, and everything's cool, okay? So you're off by 1. Of course you are, because that's the first value, so move 1 to x2, and initialize the address pointer to 1. That's assuming phase 0 will never be 0. I think that's a reasonable assumption, given the sorts of constraints I've usually seen in these puzzles. Okay. 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 Emergency coming in. P0 is 100. Move 0 to x3, so clear that out. Move 0 to x2, reset the pointer, and jump to 8. This looks good. Okay, so we keep emergencying. When emergency is cleared, read the next value, put it there, and it's all good. Okay, so I need to see it loop around now. Okay, okay. Now the real test. Will it give me test data that doesn't fit here, or otherwise will fail? Or will it be polite? Looks like it's being pretty polite so far. Okay. Whoa. Video game? You doing okay? Oh, this failed. Okay. So I do need to be able to handle tick 0 emergency. Oh, shoot, really? So it can start up an emergency state. That's... Alright, fine. So I can't do this hack. I can do a different hack! Check this out. That won't work. That won't work at all. That really will not work. Will it? Maybe! On the first non-emergency tick, you do that in it. I don't know, it might be fine. Okay, so it failed here. Non-emergency, then emergency immediately. Why did this happen? Well, I wish I could step backward. I'm gonna have to just work backward in my head here. Okay, so this... Take P0, 100. So if non-emergency, none of these are set to 0. They all fit in this so far. Why would no emergency followed by emergency leave that there? I don't have a way to breakpoint this, really. I mean, okay, which test is this that you're on? Can I breakpoint here when it gets to this test? Maybe I can. Yes, I can. Neat. Okay. So the first one goes fine. We're on the second tick here. Move 1, x2. So it deactivates that. Sets your address pointer to that. Move x0, ac. That's 1, 0. Wait. Hold on, okay, so first non-emergency tick came immediately after the... Wait, no, hang on, no, something's... I need to look more carefully at this. So no emergency. Init runs. I sleep 1. Ah, I sleep 2 when that happens. Okay, so all I change here... Sure, that's... No, wait, no, that shouldn't be a... Ah, so I need to rerun the emergency check here. At jump echeck. So yeah, that became necessary when this init code didn't immediately precede this. Okay, that should work. Right, breakpoint's there, breakpoint goes away. Yay! Alright, my cost's a little high, but I'm conventional on the other two. And you know what? I'm pretty happy with that. That's a cool solution. I'll bet there are lots of ways to approach this. I do know that the puzzle constraints specifically were made to fit within this. So like this was accounted for in the presets that are going to be given to me there. That there's no way that's an accident. So yeah, this was predicted. Do I have a wasted microcontroller? There might be a way to merge these two. Or get this down to a... Let's see, I'm not using P1. That doesn't mean anything. I don't know. There might be a way to... because this isn't using its lines, just its the pins of a MC6000. So like if I could eliminate... If I could get these X buses down to... I don't know how I'd do that, though. No, this felt necessary. All right. But somehow it wasn't. No yellow signal. Does that mean they're expecting robocars only? I wonder where they'd use this. We shouldn't speculate. It's our job to provide well-engineered solutions, not play detective with a client's overall plans. I'm assuming the way you're typing that is that this is just, like, a normal thing in the world. Okay. Yeah, I want to take one more little look at this. Like, where's an inefficiency in here? The reason these two microcontrollers are separate is so that I can use this one like a function call. There is no function return. Like, I can jump to a line, but I can't jump back to where I came. I have no RTS instruction. That would be nice if I did. But yeah, so I give two function parameters, the one that comes in on X bus that it reads once, and the one that comes in on simple pin that it reads multiple times, as many times as the X bus input. Yeah, I don't know. This it's not obvious to me where I would cut down the cost, because this all seemed very very sensible here. I mean, yeah, just the most obvious looking spot is the bottom 4 lines of this, but I need the inputs. Wait a second! I think I was supposed to have this insight a while ago. I think I just realized something. Let's actually play with this for a moment. Wait. Before I mess with it... Oh boy, it kept my undo buffer. Before I mess with it... Copy. I'm wondering if I can rely on the order that 3 wired together X buses will read things. If I can do that, then I can just wire these in series here. Have them go to one of your inputs. Okay, so we got that simple pin, the X bus pin, and things are awkward, but I can make them less awkward somehow. There are lots of ways I can do that. How about this way? Splay these all out down here. And just by, like, x2, you're right, it's x1. And this is x0. P1 is not connected there, I fixed it. SLX x1, sure. Why is this way? I want it this way. So just by physical layout, 5, 4, 2. You read the 2 first. You read the something second. I don't think this is random. Hold on, what did you... Okay, so 2, 5, 2, and... Okay, doesn't feel like I can just do that and have it work. I don't know, I feel like there's some way to make that behave, but this is not the way. So this would get me to 14 yuan. $16. Okay, so 20, 18, 16, 14, 12, no. So the scale is a little weird. So this spike is at 11 or 12, not 14, so that would only get me to here, if anything. So there's something else. To get to 12, I'd have to... Or 13 maybe, I'd have to eliminate an entire microcontroller. Okay, well, that was the best I could do, I guess. I think there's an I/O trick like this. I just think I don't know it. But there is one, somehow, probably. It's just not this. Alright, someday I'll figure out how that works, probably, but for now I'll be happy with this solution. Alright, good stuff. I'll see you next time for meat-based printer? What the heck? Well, we'll see what that is then.